are available. How to configure this watchdog? Theoretically, I will be explaining as well as in code also, and how to implement the DIT. This code will be the agenda of this meeting, of this training course. Now, in AutoSAR, this watchdog module are divided into different layers. Like coming from the top layer, service layer, we do have a watchdog manager. Then in ECU abstraction layer, we do have watchdog interface, and MCL layer, we have watchdog driver. So these are the three components of the watchdog in AutoSAR architecture. So the first thing, why we need the watchdog. So in the embedded system, this watchdog timer is nothing but it's just a basic or the essential circuit. No matter like how good is our firmware or software, there are always some unexpected situation, like your program is stuck in an infinite loop or hung somewhere, or the hardware burnout or failure happens. So to combat this kind of unexpected situations, we need some circuitry that keeps monitoring the main system or application. And in case of unexpected events, it restarts the system. So for that purpose, we need watchdog. Basically, watchdog continuously monitors the microcontroller. When we take example, when we have a laptop or TV, if there is any problem, then what we can do, we can directly go and troubleshoot. But in case of microcontroller, where we don't have direct interaction with the controller, we cannot troubleshoot, and this malfunction in microcontroller can be hazardous to human life, which may lead to life or death situation. In that case, watchdog comes into the picture, whose responsibility is to monitor the microcontroller all the time. So it basically watching and resetting the microcontroller if needed. And for this purpose, watchdog do have, in almost all the controller, watchdog do have its own independent hardware. And this watchdog has a timer, independent clock, which should not be stopped in any situation. This watchdog is basically refreshed in every particular time, and if it is not refreshed in that particular time, it results into the reset, the hard reset of the processor. So in that case, our system start from the main function again if any malfunction happens. Now, coming more into what actually is watchdog timer. So if I explain more the watchdog timer, it is a piece of hardware that uses to automatically detect software if software has any problem, and if and it resets the processor if any problem occurs. So watchdog timer is a kind of timer or counter that counts down from some present value to 0. So this timer will keep on decrementing from some defined value to 0. If this timer reaches 0, it means there is some issue with our software. Then watchdog module understand there is some issue with our module, and then it resets the controller. So that is the basic functionality of this timer. Then the first component that we have in service layer from top is the watchdog manager. So it is present in the service layer, and task of this watchdog manager is to supervise software execution. So above RT layer, we will be having many software components, and also in basic software we will be having components, maybe for memory, like that we'll be having different components. So modules. So in order to ensure if all the software components or modules are working properly, what watchdog manager does, it has assigned those components or modules, and those assignment is called the supervision part. supervision software, the software which need to be supervised by WatchDog manager. So basically this software component is using the services provided by WatchDog manager by using the client server interface. So here if you see this software component 1, SWC1 is nothing but a client, and WatchDog manager acts as a server in the service layer. And WatchDog module do provide some APIs like I will be covering next slides. It provides some APIs which needs to be triggered or serviced in order to get the service to detect if software modules or software component or base software modules are working properly or not. Now this supervision can be of 3 types. So if you take any AutoSAR stack for WatchDog module, you will find this 3 supervision for software component. First is alive, then deadline, and logical. So alive is nothing. Alive is nothing but it tells. Let's suppose we have a software component which is being running in every 10 milliseconds. Now what this alive supervision tells, if our software component is running in 10 milliseconds and after 50 milliseconds, if WatchDog module want to see if this software component is working properly or not, what it does, it has a flag. It has a counter which will be increasing every time the runnable is executed. So we provide in configuration like for every 50 millisecond, WatchDog module should check if this software component is running properly or not. Since this software component is running in 10 milliseconds, so after 50 milliseconds, that counter value, that variable value will be 5. Because 5 times it would have been executed in 50 milliseconds. So in configuration, what we does, we provide the minimum value and the maximum value. It might be possible that once it has been skipped, so we provide a minimum value for the WatchDog module for that software component, and also the maximum value. So we provide a range of 40 to 60 and tells, okay, if count is 4 to 6, sorry, if the count variable count is between 4 to 6, then it means software component is working properly. Otherwise, if count is 3 or if count is 7, it means something is wrong. Either the software component is not working properly, it's working very slow, or it is working very fast. It means there is some issue and it needs some supervision and a reset is required. Then WatchDog module provides information to the WatchDog hardware to reset the system. Deadline is, let's suppose I do have a software component which is again running in 10 milliseconds, and I know in order to run this software component, X amount of time is needed from the starting of this module to the end of this module. So deadline means how much minimum or the maximum time needed in order to execute a software component. So here also we provide a min-max time. Let's suppose I need a component that should be completed in 2 milliseconds, let's suppose. Then what I do, I provide a minimum time 1 millisecond and maximum time of 3 milliseconds, and I tell, okay, this software component should be completed within 1 millisecond to 3 milliseconds, because that's the deadline of the software component to be executed in that periodicity. So my WatchDog module will be serviced in every 1 millisecond to 3 millisecond of that supervised component, software component. And if elapsed again, if that software component is being executed before 1 millisecond or after 3 milliseconds, then and again a reset will be happen. System reset will happen, hard reset. Then logical kind of supervision is, as we know, when the system starts. Okay, one use case I will be giving, like when the system starts, it goes from init and then the main runnables are started. So in order to understand if the logical flow is correct or not, for that purpose we use the logical supervision. Like first init happened and then main runnables are running. So that kind of flow execution is being checked in logical supervision. So we can have a software component which, let's suppose I need a NFC to run. For that, I need voltage monitoring should be done. Before that, ADC init should be done. All those things. So what I will be doing in configuration, I will be providing a checkpoint that first ADC init should happen. After that, a voltage monitoring should happen. After that, NFC main runnable should run. So if all this thing is happening in a sequence, then it means my logical flow is fine. My flow execution is working properly. If not, then it means again some issue has happened and I need to reset the system. So that kind of supervision is done in logical supervision. Now, types of WatchDog. There are basically two types of WatchDog: normal WatchDog and window WatchDog. So, normal WatchDog, till now you would have listened, like if I am configuring a WatchDog for 50 millisecond, and in that 50 millisecond, if my WatchDog is not refreshed, then a reset happens. That is called immediate or normal WatchDog. This one is normal WatchDog. It is basically a timer, so it keeps counting down till 0. As long as all the tasks completed in approximate pre-computed time before tick counts reaches 0, WatchDog repeatedly reinitialize the tick counter at the end of the loop. So what it is actually doing, I have assigned this configuration of WatchDog is done in a way that most of the modules ends their execution before the WatchDog timer reaches 0. So that once the task is completed, I can refresh my time again so that the WatchDog timer never reaches 0. If it reaches 0, it means there is an issue. There is an issue reaching out to that piece of code where I am refreshing the WatchDog. So, and since it is having its own hardware and its own clock, whatever the case be, if my code is stuck or if my code is not working at all, at that time also the WatchDog timer will never stop. It will still start. It will be decrementing. It will just decrementing, and as soon as it becomes 0, that WatchDog timer, it will initiate a hard reset. So when it is done, like when this reset happens, it is like some unexpected situation. Some unexpected situation, like task has been stuck or hangs or taking a longer time than usual. So at that time, the hardware or the WatchDog hardware module asserts reset signal to CPU. Then CPU just what it does, it resets the system, means it is just like power on. And this last line is telling it is not necessarily that WatchDog module provides a reset signal directly to the CPU. It in some complex architecture, it might be possible, like when we have a multi-core system, there the impacted core provide information to the main core, and then from there a fault management system unit is described that is responsible for initiating a reset, providing us information to the CPU to initiate a reset signal. Now, the other type of WatchDog is window WatchDog. So here, if you see this diagram, there are 3 regions. First is this pink region is underrun, second is normal operation, and third is overrun. So in this window WatchDog, what happens? If you see this, the upper one, 0 cross FFFFF, this is nothing but during configuration we have reloaded that window WatchDog variable with some value, and here let's suppose I have given the, and this is nothing but a timeout value for our WatchDog. If this is set as timeout value, so in normal WatchDog, what happens if my WatchDog is not refreshed within this timeout value, then a reset occurs. But in window WatchDog, we provide a window, a minimum time and a maximum time. Let's suppose this is my 10 millisecond. The upper timeout value is 10 millisecond. And then window time, this green region I'm describing as 5 millisecond to 8 millisecond, let's suppose. So in window watchdog, what should happen? My refresh mechanism should happen within this time, 5 millisecond to 8 millisecond. Then only a proper watchdog refresh is computed. If my refresh happens below 5 millisecond, like in this case, my refresh happened below 5 millisecond, then a reset is occurred. If my refresh occurs above 8 millisecond, then also a reset is happened. A reset will never happen only if and only if my refresh is happening between 5 millisecond to 8 millisecond, and that is called window watchdog. Time and in that window watchdog, this arrow, what you see here, this is the window refresh start time, and this is the window refresh end time, and all the refresh should happen within this 5 millisecond to 8 millisecond, not above, no, not below, not after 10 millisecond. Otherwise, it will reset. It will send a reset signal to CPU. So this kind of architecture, watchdog architecture, is called window watchdog. And yeah, so this is whole about watchdog. What actually is normal watchdog, immediate watchdog, window watchdog, and then